Okay, so this introductory page in your notes I'm kind of calling 2.0 as we get to know this new topic. This unit is all about working with quadratic equations. Does anybody remember anything about what we refer to as quadratic equations from last year?
I do not.
So a quadratic equation has an x squared in it. Last unit, we were only doing linear functions, right? There were no exponents attached to the x. In this unit, we will be working with primarily a lot of different x squared functions. So let's get us started. We're going to start by multiplying binomials. How are we feeling about this one here? We're going to do things like distribute on through. Yes, I will be writing back here so that everybody can see it. I'll try to write a little bit bigger. Let me know if you cannot see. So are you talking about the exponent? How did I get an x cubed? I have an x squared here, and I have an x to the 1 here, and when we multiply like bases, we add the exponents together.
Wait, how do we get the cube?
I just explained that. That's all right. So I have an x squared, and when I multiply an x squared times an x to the first, I keep the base, add my exponents. That's just kind of the rule of thumb when we're working with exponents. Now looking at letter B, we're still multiplying. We've got two different binomials. Anybody want to tell me what we do when we see this? We are going to, have you guys learned FOIL?
No.
One times one.
Yeah. So,
We did one equation, we did not learn it.
all right, well, let's identify what FOIL means. You're going to multiply your firsts in both of the binomials, then your outers, then your inners, then your lasts. So I multiply the first, and I'm going to write this in one long string across my board here. So I get 3x times 2x is 6x squared. Now I'm going to do my outers. 3x times positive 5 plus 15x. Negative 1 times 2x, negative 2x. Negative 1 times 5 minus 5. Once I've FOILed, I always try to see if I have like terms to combine. Here, right, these two terms here can be combined together. So my final answer is 6x squared plus 13x minus 5. Questions? There's nothing to solve. There's no equal sign in any of these, right? Nothing is set equal to anything that I'm trying to solve for anything. All I'm doing is just kind of combining like terms, multiplying. Go ahead, try letter C on your own. You'll have to do the same thing of FOIL.
So maybe you guys should like switch sides.
No. I refuse.
That would be smart.
Stop.
If you want to write it out as a 1x, that's perfectly acceptable if you want that placeholder.
Oh, I'm so close.
No.
Well, I got that answer. Yes.
Any questions on how to multiply those binomials and combine like terms? All right. I know I'm back here, but everybody stay with me. The next section in your notes is figuring out what are called perfect squares. So a perfect square, let's define it to make sure we know what it is. When you take the square root of a perfect square, you get a whole number. So in order for it to be a perfect square, Like 2, for instance, is not a perfect square. When I take the square root of 2, I do not get a whole number. Whereas when I take the square root of 4, I do get out a whole number. The square root of 4 is 2. So go ahead and fill out all of these perfect squares. If you want to use your calculator, go ahead and do it. Yep, fill them all out. You got it. You can do it. You will need to have at least up to 15 squared memorized is my recommendation.
For the past like 6 years.
I know up to. I know. I know I'm. You can't remove 6 and 4.
I'm giving you up to 15 squared. The rest I would like you to fill in. Fill in yourself. Use that calculator. Make sure you know how to use the squared button. Yep, you can use the caret and then type in 2, or you can just use the little x squared button on your calculator.
Yeah, Mr. Howard, since he puts his microchip in and then he knows everyone to help.
I think Mr. Howard tossed him 1 I think.
Yeah, because Mr. Howard's a physics professor, not a math professor.
Okay.
All right, guys, I realize I'm back here. Just do it. Just do it. I'd like to move on quickly.
Well, you should know this because we don't move.
Yes, you do. I will.
Did you go take good here? Did you like it?
I did it in my head. 13 squared? That is almost a funny number. It's not. Head 100. If you take the number and subtract by error, then it's a funny number.
All right, we are moving on. These are all perfect squares. All the numbers that you have written in, right? These numbers here, those are examples of perfect squares. All right, simplifying square roots. Did you do this last year?
Yeah.
Okay. So all those numbers that you just wrote in, imagine as if those are the only numbers in existence. When I simplify a square root, I need to figure out what is the biggest perfect square that divides into that number. So you're always asking yourself, okay, I've got 162. What is the biggest perfect square that divides,
81.
yes, into 162? So I recommend starting big, right? 144, it's not going to divide in, but start up high and then work your way down low. This is the way I show it. I know some teachers may show it differently. 162 is 81 times 2. So I just change what's under my radical to be 81 times 2. That's a multiplication. I then break that out into each radical. One of the rules of square roots of radicals is that I'm allowed to do that. Notice I always put the perfect square first. What is the square root of 81?
9.
That is my final answer. If you pick up your calculator and type in the square root of 162, does everybody know how to type the square root button on these calculators? It is second x squared. Second x squared will give you the square root button. These two radicals here have the exact same decimal representation on your calculator. So all we've done is simplified. The answer that you will see on an ACT will always be a simplified radical. So that's why we need to make sure we know how to simplify them. All right, what is the biggest perfect square that divides into 32? 16. It is not 4, it is 16. So I'm going to break out 32 into 16 times 2. The square root of 16 is 4. I do not like the trees. The reason why I don't like the trees, people keep going down the branches. They will say, oh, and the square root of 4 is 2, and the square, like, no. I write it exactly like this, and once I'm done simplifying, I'm done. I get it. If you've learned differently, keep using the strategy that works for you. This is how Miss Sedlick's going to show it in her notes. All right, what's the biggest perfect square that divides into 18?
9.
So I now have a number out front, but I'm really going to treat it the same way. What operation am I performing between the -3 and the square root of 18? I am multiplying. Sometimes when students do this, a like phantom addition sign pops out of nowhere. I am multiplying these, at this point, 3 things. So I wind up with -9 square root of 2. All right, and our last one, what's the biggest perfect square it divides into 12? Questions? So what we're going to do is we're going to break for a second and do some practice just to make sure we've got this down. Not on. This is not homework, this is classwork. You do not need to do all of these. Let's do, you want odds or evens? Even. Let's do the evens.
Because it's on the left side.
Nice shot.
I said even.
As in Steven. You're on. Move this here. You're right on the very end. I think it is like.
You. 36. Yeah, I literally that was right here.
6. Wait. Interesting. That is totally true. 18.
I didn't pay attention to this passing
No, it's
like I was just messing up.
of course.
No, you don't.
You make any other words? Oh my, 6 is just not okay. That's so mean.
6 is so mean. Yeah.
That's just really. That's disgusting. Actually, utterly disgusting. I'm ashamed.
All right, so we are now transitioned back into our notes. Let's finish up this front page. What is the parent function of a quadratic? So a parent function is basically where do we start off before we start adding in lots of extra numbers and stuff like that. The parent function of a quadratic is y equals x squared. So a quadratic implies that we have an exponent of 2 on the x. Anybody know the shape that an x squared function makes?
Like
Circle.
this one. Oh, this one. No. Is it like the?
It is a U shape
I was so clear.
called a parabola. It can be an upward facing U or a downward facing U. Now what I'd like you to do is you have some extra room at the bottom of your notes there. I would like to add some new questions where we will be factoring out the greatest common factor. Let me see if I can make that a little bit bigger. So add those at the bottom of that page. Add these questions at the bottom of that page. we will be factoring out the greatest common factor. This is also a fundamental skill. I need to figure out if we need more practice with it.
I have no idea. But what's
Wait, this is not hard then.
You are writing this down.
I have no idea what the 150, that's too big for my I'm not enough room for this. Look, look at this. How did I get D?
I'm still running. Okay, my right eagle. Oh. And Z.
All right, now that we have these written down, let's look at letter A. So what I'm trying to do is I'm trying to figure out what is common to both the term up front and the term in the back. 7, is there anything else that's common? X, what else? How many y's? Y squared. Okay, so what I'm going to do is I am going to kind of reverse distribute. I am going to divide it out of each of those terms. So I started with 14x squared y cubed, and now I'm going to divide out my GCF, which is 7xy squared. So what I am left with, 14 divided by 7 is 2, x squared divided by x is x, y cubed divided by y squared is y. Okay?
How do we get the 2y for the 7x to y2?
How many y's are in this first one?
3.
How many are in this? 2. So what's common? 2 y's. There are 2 y's at least in both of these. So think of this first one. This is 14x times x, y times y times y. Over here, we have 7xy times y. So what's common is we've got 2 y's, 1x, and then the 7. So that's how we figure out our greatest common factor. Now I'm not done. I have a 7xy squared, right? That's what I started with. And I'm dividing out 7xy squared.
1.
Yes, I need that placeholder of a 1. So what we have done, like I said, is we've kind of reverse distributed. I divided that out of the terms. If I want to check my answer, did I divide out my greatest common factor correctly? All I have to do is distribute this back through, and I should wind up where I started, which is up here. Let me erase all that so we can see it. Questions there? Yep, Will?
You just create an endless cycle of math.
Oh my God.
It's basic.
And then taught us how to undistribute.
Right. It's like if I teach you how to add, shouldn't I also teach you how to subtract?
No.
Okay.
No, why would you do that?
All right, let's look at our next example. We've got a negative 4z to the fourth minus 16z cubed. What is common to both of those?
And 4.
I don't know.
Negative 4z to the third.
Negative 4z to the third. Good job, Dylan.
That way, Dylan.
Succinct. I like it. So if I started with negative 4z to the fourth and now I'm dividing out negative 4z cubed, what am I left with? Just a z. If I have negative 16z cubed and I'm dividing out negative 4z cubed, what am I left with?
4.
Positive 4. Correct. So this kind of like side work where I'm doing the division by hand, you will eventually not need that. You will start doing a lot of this in your head. But for now, if you want to write out those divisions, go ahead and do it. All right, you want to try letter C on your own?
No.
Okay, let's do it together. What is common to all three of those?
25N.
25n. Perfect. So I started with an n to the fourth, but I'm going to divide out an n. So I need an n cubed, and I need what number? What's 150 divided by 25?
6.
6 n cubed plus,
Because you do 25, you could n 4 divided by minus 10.
there we go.
Oh, I put 2 and okay.
I'm slightly scared.
All right, how about our next one?
Like
3.
How many n's?
2.
There we go. And then our last one.
Is
One.
the
Plus 1.
You need that placeholder of the +1. If you don't put in that placeholder, then you are going to kind of miss out on what you need to do. All right, that concludes 2.0.